Hello, Math Humans. We're going to do 5.6a today. We're going to be doing some work with our inverse trig functions. So most of today's topic is just a review of information that we learned in pre-calc. So remember that there are 6 trig functions that we manage. There are more, but we're only going to manage 6, and that would be sine, cosine, tangent, and then the reciprocal relationships, cosecant, secant, and then cotangent. So if you will remember from math that we did last year in pre-calc, remember that we have to restrict the domain to be able to have an inverse function. So we're going to restrict our domain so that we can have inverse functions. Remember that those inverse functions are going to be the arcs. So you could write it, so if I have sine, then maybe my arc is going to be written as the inverse sine, or I could write it as the arc sine. Both of those expressions are used interchangeably, and those are the inverses. So if I restrict the domain of sine, right, that means that I'm going to restrict it to the first and fourth quadrants. Remember that the rotation is either this direction or this direction. You cannot go all the way around. So it's only the first and the fourth quadrants. So arc sine is restricted to quadrants 1 and 4. Okay, if I have arc cosine, cosine, that is restricted to quadrants 1 and 2. Okay, if I have, and I'm leaving some space on purpose because we're going to look at the graphs, if I have arc tangent, that is also restricted to 1 and 4, okay? So let's go back and look at the graphs of sine and cosine and then look at the graphs of their arcs. So if I restrict the domain for sine to a negative pi over 2 to a positive pi over 2, then my sine graph is going to look like this, and then it tops out at 1 and it has a bottom at a negative. So this is y is equal to the sine of x. If I graph y is equal to the arc sine of x, then that's going to go, remember the domain and the range flip for our inverse functions. And so this is going to be pi over 2 and a negative pi over 2. And then arc sine is going to look like this. So it looks like the same basic graph. The biggest thing to notice is that my domain and range have switched places. For arc cosine, so let's look at y is equal to the cosine of x, okay? So cosine is going to start high, and if we go from 0 to pi, so this is 0, it's going to cross at pi over 2, so cosine looks like this. And then if I graph y is equal to the arc cosine, okay, and I restrict its domain to the first and second quadrants, so this is a negative 1, this is 1, and then this is going to be pi, and then, and then that's going to be pi over 2, then it's going to cross at pi over 2 and go down to 1. Boy, I'm really not batting 1,000 on the graphs this morning. Okay, so that would be the graph of our cosine. Tangent is limited to the first and fourth quadrants, just like sine. So if this is a negative pi over 2, remember that tangent has vertical asymptotes at pi over 2 at the odd multiples of pi over 2. And so my graph for tangent would look like this. That's y is equal to the tangent of x. Then if I graph y is equal to the arc tangent of x, then that would be, it's actually kind of cool, it looks like a logistic growth function. So this would be my pi over 2, this is my negative pi over 2. You can't see that, now you can. And then that would be the graph of arc tangent. So a couple of things to remember about the notation. So if I want to do the sine of pi over 6, that means find the ratio. If I want to do the arc sine of a half, that notation means find the angle. Okay, and remember, if we're doing our specials, we can do that math by hand. If we're not doing specials, then we have to push buttons on our grapher. Alrighty, remember for calculus and big kid math that the default for your calculator, ULT, is always going to be radians. There are potentially cases where you would need to put your calculator in degrees, but at that point, you're just going to make sure that you read the problem well. Remember that we need to do our specials, and we've been using those all year long, so I'm not going to review them. And we also need to draw and label our reference triangles. Remember not to skip this step because in theory you have not memorized the unit circle, but you're just regenerating as we go. So if I had something that said the sine of the arc sine of x, okay, this is called a composition. We did those in pre-calc, and that's going to give you x. Where people get in trouble is if I have something that's outside of the restricted domain, so you just have to be careful with the math, okay? And so in theory, the same relationship applies. Cosine of arc cosine of x is also x, and the tangent of the arc tangent of x is also x. You do have to be careful, and I usually do these out because sometimes I just, depending on where the domain is restricted, I don't want to make mistakes. So let's do our first example. And I'm going to be asked to solve, and I'm going to have the arc tangent of 2x minus 3 is equal to pi over 4, okay? So one way of managing this is kind of like when we did log problems where I took the log of both sides. So I'm actually going to take the tangent of both sides. So I'm going to do the tangent. So I'm going to create a composition of the arc tangent of 2x minus 3, and I'm going to get the tangent of pi over 4, okay? So I can do anything I want to an equation as long as I do it to both sides, and so that's what we've done here. So remember that this particular composition is going to be the inside, so I'm going to get 2x minus 3. The tangent of pi over 4 is 1, so then I get 2x is equal to 4, and x is 2. So it was actually fairly straightforward. Okay, it's just a new application by taking the tangent of both sides of the equation. So for example number 2, let's scoot my paper up so you can see, I'm going to be given that y is equal to the arc sine of x, and I'm going to go 0 is less than y is less than pi over 2, and I want to find the cosine of y equals what? Okay, so the first thing that I'm going to do is I'm going to manage this information. This equation, the arc sine of x, says what angle, what theta, has a ratio of x over 1. Okay, so what I'm going to do is I'm going to draw that triangle. Okay, remember arc sine is limited to the first and the fourth. Sine is positive in the first. Sine is x, this is 1. Well, by the Pythagorean theorem, there's my cute little angle theta. This is going to be the square root of 1 minus x squared. Well, now I know everything so that I can actually find the cosine of the same angle. So I'm going to say the cosine of y is equal to 1 minus x squared over 1, and so then I would just write it as 1 minus x squared. So that was actually kind of entertaining. All right, next example, example number 3. We're going to be given y is equal to the arc secant of radical 5 over 2, and it says find the tangent of y. Okay, so we're going to approach this problem the same basic way that we did. Remember that secant is the reciprocal of cosine, so that means that this ratio is going to be r over x. Okay, so when I draw my reference triangle, so arc secant is the reciprocal of cosine, so that means the domain has the same restrictions as cosine. Arc cosine is limited to the first and the second quadrants. Cosine is positive in the first quadrant, so I'm going to make this be radical 5. This is 2, okay? And then again, by the Pythagorean theorem, I can find that y is equal to 1, okay? And again, I'm using the Pythagorean theorem. And since you're in big kid math, I'm assuming that you can pull that off, okay? Well, if I know y and x, now I can do tangent, because remember that the tangent of an angle, which I call theta, but technically is y, the tangent is y over x, or it's sine over cosine. So the tangent of the angle is going to be a half. So that was actually a very easy problem. All right, we have 2 more examples. So example number 4, I'm going to evaluate the tangent of the arc cosine of radical 2 over 2. So let's go back and remember from pre-calc, we talked about it's easier to unrationalize these particular values. So I'm going to rewrite this as the tangent of the arc cosine of 1 over radical 2. Okay, now it makes this part easier. This is a composition. We always start on the inside. So arc cosine of 1 over radical 2 says find the angle. Cosine is positive in the first quadrant. Cosine is 1 over radical 2. That means that this is also 1, right, because it's going to be 45, 45, 90. And then this says do the tangent of the same angle. Okay, technically the angle is pi over 4, so I'm going to go ahead and write pi over 4. Well, the tangent is 1, and I'm using the same drawing, super easy to manage, okay? And then if I were reporting well, I would say the tangent of the arc cosine of 1 over radical 2 is equal to 1. Alrighty, for our last example, example number 5, I want to solve, and we're going to have the arc tangent of 2x minus 5 is equal to a negative 1. So I'm going to approach this problem very similarly to the one that we did earlier. So I'm actually going to take the tangent of both sides. So I'm going to do the tangent of the arc tangent of 2x minus 5, and I'm going to do the tangent of a negative 1. Okay? This is going to give me the inside. So we have 2x minus 5. Tangent is a negative 1 right here. Okay, we're going to take the first time that it occurs, and this is 3 pi over 4, right? So I'm going to say that this is equal to 3 pi over 4. Remember, radians are the default. So 2x is 3 pi over 4 plus 5. X is going to be equal to 3 pi over 4 plus 5, technically divided by 2. And then depending on whether or not you needed a decimal equivalent, making sure that your grapher is in radians. Actually, it doesn't matter at this point because these are just numbers. And then I would have my solution. So that was pretty nice and straightforward. That's it for today, my dears. I will see you soon.